Assalamualaikum and very good day to everyone. My name is Nisa Naziha binti Norzali from the FYP Shah. I will be presenting my final year project entitled Assessment of Microbial Contamination of Prayer Mats used in public prayer rooms around the FYP Shah under the supervision of Dr. Nurul Aini Zakaria. First, I will start with the background of study. Prayer mats are essential for Muslims to complete their prayers, and they are provided almost in every mosque and prayer rooms. However, prayer mats may act as reservoirs for bacteria due to frequent skin contact during prayer. A study by Ozdemir et al. Detected various bacteria and fungi isolated from samples of carpets in mosques. For instance, Staphylococcus aureus are isolated, and 19.5% of that particular strain are methicillin resistant. The presence of water is the key factor for bacterial growth and reproduction. In prayer rooms and mosques, prayer mats and carpets may become moist when people enter without properly drying their feet after ablution. This creates a favorable environment for bacteria to survive and multiply. Next, we will move on to the problem statement of this study. Although prayer mats are commonly used in Malaysia, there is limited research that specifies microbial contamination of prayer mats in public prayer rooms. Also, there is lack of detailed information regarding which specific areas of the prayer mat that can accumulate the most microorganisms. This study focuses on the following research questions. The first one is which area of the public prayer mats have the highest and lowest microbial load? Second, what types of microorganisms can be found on public prayer mats? And lastly, what are the susceptibility patterns of isolated microorganisms against several antibiotics? Hence, this study aims to compare the microbial load on different parts of the prayer mats and to isolate the microorganism from shared prayer mats. In addition, this study also aims to determine the antibiotic susceptibility profiles of the isolated microorganisms against several antibiotics. So what makes the study on public prayer mats important? The findings from this study will provide area-specific data on bacterial load and distribution of bacteria across different parts of shared prayer mats. This information allows the development of cleaning routine procedures or targeted cleaning and disinfection of prayer mats to reduce disease and prevent infection, which contributes to SDG 3, good health and well-being. Now, we will move on to the literature review, and we will discuss why prayer mats are considered high contact surfaces. Prayer mats are commonly made of wool or nylon. Wool can retain water up to 1/3 of its weight, while nylon is hygroscopic, which means that it can absorb moisture from the surrounding air. These characteristics allow the fabric to absorb body fluid, such as sweat and sebum, which are essential nutrients for microbial growth. Moreover, a significant portion of Muslims attend mosques up to 5 times a day for their daily prayers. Based on figure 1, prayer rooms are the busiest during Zuhr prayer between 2 to 3 p.m. and during Maghrib prayer between 7 to 8 p.m. This constant rotation of users increases the potential for microbial accumulation. Here, I compared the different methods used in 2 previous studies by Ozdemir et al. And Al-Saif et al. The method used is almost similar, and they successfully identified several significant bacterial species such as methicillin-resistant S. aureus or MRSA, Pseudomonas aeruginosa, Bacillus species, and one of the factors that contributes to microbial transmission in mosques and prayer rooms is the relative humidity. The use of air conditioning split units may produce moisture that favors bacterial and fungal growth. In addition, foot, hand, and face contact could enhance microbial transmission because the faces are touching the carpet during the prayer, and people breathe towards the carpet and transmitting their own flora or pathogenic microorganisms to the carpet. Next is the effect of bacteria found on prayer mats and carpets on health. S. aureus, Salmonella species, and E. coli have been reported in samples of carpets taken from mosques in Tripoli, Libya. S. aureus can potentially cause infections ranging from minor skin infections to life-threatening systemic illnesses, while Salmonella species and E. coli are major causes of bacterial diarrhea, particularly in children. We will move on to the methodology part. First, the samples will be collected from 2 different areas, which are the forehead area and the edges of the prayer mats. The samples will be collected with a sterile swab moistened with sterile saline water. Second, the samples will be stripped onto neutron agar and also on selective medium. The selective mediums are blood agar and McConkey agar. Blood agars are used to observe the hemolytic activity of the bacteria, while McConkey agar will select for gram-negative bacilli and differentiate lactose fermenters from non-lactose fermenters. Next, a lookful of bacteria from the agar was used to prepare the inoculum in bulk. The broth is then serially diluted until it reaches the dilution of 10⁻⁴. Each of the dilutions will be plated onto neutron agar by using spread plate method. This experiment involves plate count method and it will be performed in triplicates. The FH data will be used. Hence, the CFU between two different areas, which are the forehead area and the edges of the premass, can be compared to identify which area accumulates the most microorganisms. The biochemical tests that will be used on colonies that grow on McConkey agar are oxidase test, triple sugar ion test, and IMVIC test. While the biochemical tests that will be used on colonies that grow on blood agar is gram staining, catalase test, and coagulase test. Lastly, an antibiotic sensitivity test will be conducted, and this step involves the 3B-Bauer diffusion, minimum inhibitory concentration, and minimum bactericidal concentration. The 3B-Bauer diffusion involves 4 different antibiotics. After the Mueller-Hinton broth is inoculated, the antibiotic discs will be placed aseptically using sterile forceps. After incubation, the diameter of the zone of inhibition formed around the disc will be measured. The MIC step will be using the same 4 antibiotics that used in the previous step. And this part used a broth microdilution method and involve a 96 well plate. The antibiotics will be diluted to form multiple concentrations of antibiotics. Then bacterial suspension with the same volume will be added into each well and it will be incubated. After incubation, the turbidity of each well will be observed and the content of the wells where no turbidity is observed is the MIC. For MBC, each of the wells with no turbidity will be plated onto MHA plate and any bacterial growth will be observed. Next, these are the list of materials required for experiments included in my study. The first expected outcome of this study is that the microbial load from the forehead area is expected to have higher CFU compared to the edges of premax. Second, gram-positive bacteria such as Staphylococcus species and gram-negative bacteria such as E. coli are expected to be isolated from shared premax. The third one is that isolated microorganisms are expected to be resistant to common antibiotics such as amoxicillin and tetracycline. This Gantt chart shows different stages of the project. And these are the references that I referred to throughout my presentation. So that's all for my final year project presentation. Thank you for your attention and Assalamualaikum.